Should I start or I will wait a few minutes? I think I should start now. Okay. Okay. I think my screen is visible to you clearly. Hello.
Yes, yes.
Yes. Yes. Okay. Okay. Thank you. Thank you. Okay. Okay. This is the week 3 lecture series I will discuss here. Okay. This is Subrata Kumar Maiti, PMRF students. In the week 3, what we will discuss first thing we will discuss the methane decomposition process. Okay. Methane decomposition process means that the CH4 will be decomposed. Okay. And some other process for producing hydrogen, like hydrogen is produced from biomass. Okay. And hydrogen, and second part and third part is the hydrogen is produced from coal. Okay. These three uh, topic will be covered here in the week 3, and the discussions will be going on in this series, in this lecture series. Okay. And next, finally, we will do some numerical, and we will see some sort of assignment questions too. Okay. Starting with the methane decomposition process, as you know that methane, that means CH4. CH4 will be decomposed. As you know that it is uh, constituted of carbon and hydrogen. If it is decomposed, the hydrogen gas will produce. Okay. It is also endothermic process, as the positive sign is here, delta H. That means this much of amount of heat is required for producing for 1 mole of methane decomposition. Okay. What is the main advantages and disadvantages of this process? Earlier we have seen that water gas shift, steam methane reforming process. Okay, what was the steam methane reforming process? The steam methane reforming process is like this, uh, that uh, steam, that CH4 plus steam. Okay, it is producing syn gas, that means carbon monoxide plus 3H2O. Okay, what is happening here? Here both the gases is producing carbon monoxide and hydrogen, both are in gas phase. Okay, it is difficult to separate the hydrogen gas from carbon monoxide gas. Combinedly it is called syngas. Okay, but here in the methane decomposition process, what is the advantages of methane decomposition process? Directly methane is decomposed and it is producing carbon in solid form. Okay, carbon in solid form and hydrogen in gaseous form. Okay, hydrogen in gaseous form. So what is the advantages? The advantages is that our main motive is to generate hydrogen gas. By decomposing methane, we can easily generate hydrogen gas and we can easily separate it out from carbon, as byproduct is carbon, it is in solid form. Okay, and gas is easily, we can separate hydrogen gas from solid. This is the main advantages of methane decomposition process. And actually, as you know, as ma'am has discussed, that efficiency of this process is very less. This is less efficiency, low efficiency. Okay, low efficiency. Earlier this process was very popular, but nowadays, but in between, then this process was not popular because the efficiency was very less. But somewhat nowadays this process is becoming very popular. What is the popularity? Why it is becoming popular? Okay, but because in this process, whatever the carbon is generating in the solid form, carbon, whatever the carbon is generating, carbon has a very large applications in chemical industry. Like, you know that carbon can be used as catalyst industry. Carbon may be used in energy sector, energy generation sectors. Okay, as I am working in fuel cell and water electrolyzer case, this carbon cloth or carbon will be used as a electrode material. Okay, not exactly electrode material, but we will deposit some electrode on this carbon paper or carbon cloth. And you know that the graphene oxide, geo, graphene oxide has very high promising material nowadays, nanomaterial. It is very high promising. This is also some sort of carbon material. Okay, it is also produced from graphite. Okay, this is very high costly material, geo. Okay, and I think you also know that the CNT, carbon nanotube, this is also very high, good nanomaterial, very promising nanomaterial. Nowadays all the researchers is doing or using this sort of nanomaterial. Okay, actually, by the using this methane decomposition, we can generate different carbon solid, like a geo, carbon nanotube, or carbon multi-wall nanotube. Okay, multi-wall nanotube. This is also very good uh, nanomaterial. Okay, by using this methane decomposition process, we can get hydrogen as well as different sort of carbon material in form of different carbon form, like geo, CNT, MWCNT, multi-wall nanotube. Okay, and another advantages is that, what is the another advantages? In this process there is no carbon dioxide produces. Okay, no carbon dioxide produces, no carbon dioxide. Okay, This is our advantages. There is no carbon dioxide produces. So this is obviously one green productions, you may say, okay, or energy or environmental friendly process, you can say, okay. And in this process, if we use, there is the process we can use catalyst in this process or non-catalytic process, okay. If we use, obviously you know that the, if we use the catalyst, if we don't use catalyst, the reaction temperature is like 1100 degree centigrade to 1300 degree centigrade for non-catalytic process. If we use the catalyst, the temperature will reduce, okay, temperature will reduce, the Rika temperature will 500 degree centigrade to 800 degree centigrade or 900 degree centigrade, okay, 900 degree centigrade if we use catalyst, okay. If we don't use catalyst, the reactions will be at higher temperature, it will around above 1000 degree centigrade, okay. And as you know that the carbon will produce as a solid form, this carbon will deposited if we use catalyst, if we use, suppose this is catalyst, in this process the catalyst is used same, the highly promising catalyst, like you always knows, nickel is a very high catalyst, iron is also good catalyst, cobalt is also very good catalyst, okay. This type of catalyst is used in the methane decomposition process, okay. We know that the in this process, what is producing, the producing is the carbon solid, okay. This is the carbon solid, okay, this is carbon, this is nickel catalyst, I think this is nickel catalyst. The production is this is the byproduct, carbon is a solid form. This solid form carbon can deposit on the nickel, can deposit on the nickel, and it may reduces its active site, catalyst active site. This is how, as the reaction goes on, okay, the catalyst activity will reduce. What is our main motto? We have to design such a way that catalyst deactivations will be in a longer duration time. Catalyst deactivations will take longer durations time, okay. This is the main objective of the methane decomposition for hydrogen production process. Here I think you know how the reactions will, the reaction mechanism actually. This is the reaction mechanism. This is very simple. There are two types of reaction mechanism. One is the free radical mechanism. This is the free radical mechanism that initially the methane will produce that the CH3 radicals. This is the CH3 radicals. Radicals always written in the star form. Okay. This is the single hydrogen radical, okay. In this process again this CH3 radicals will decompose CH2 radicals, this is CH2 radicals, and this is again hydrogen radical, this is again CH radical, and this is finally the carbon radicals will occur, and this carbon will radicals will react and it will form solid carbon, and hydrogen radicals, two hydrogen radicals will react, that the hydrogen gas, okay. This is the hydrogen gas, okay. Whatever I discuss, whatever I told you, that in this process the different carbon product will obtained, okay. The different carbon product we may get, okay, like CNT, multi-wall nanocarbon tube, and amorphous carbon particle, okay, and some highly crystalline carbon solid, okay. These are the carbon solids, these are the carbon product, and different carbon product has different applications. This is very promising material nowadays, okay. And second mechanism is the stepwise dehydrogenations, okay. This is also very simple process that CH4 will decompose, all the cases the decomposition reactions is occurring. Here final step, it is like it is like some different initially the lower order carbon, then it is forming the higher order carbon, and then it is forming acetylene. It is a very stable form. Okay, that's why, sorry, this is the acetylene, this is the acetylene, this is very stable form, and finally this acetylene will decompose and your final product will carbon. Okay, and this is the how the CH4, how the CH4 is decomposing, how the CH4 mechanism is like this is also producing CH3 radicals and hydrogen radicals. CH4 is also again reacting with hydrogen radical and it is forming like this, and this is a C2H6 and C2H6, this formation is, and finally the carbon will, all the cases, in all the cases for free radical mechanisms and stepwise dehydrate generation, all the in the cases the final product will be carbon solid and hydrogen gas. Okay, and I already told you the some higher unsaturated hydrocarbon and aromatic hydrocarbon will produce. These are the very, these are very promising applications in different chemical industry or different energy sector. Okay, next is the catalyst. Different catalyst is used. I told you that the nickel catalyst is very good catalyst, and iron is very good catalyst, and nickel and bicatalyst like nickel and copper, and carbon is also used as a catalyst. Okay, and other metal catalyst like cobalt, platinum, palladium, chromium, and molten metal catalyst is also used. Okay, different, if we use different catalyst, the different carbon formations, it is in solid form, different carbon formations or different carbon structure will generated. Okay, what is the nickel? The nickel catalyst generally works in between 500 degree centigrade to 650 degree centigrade. Okay, nickel has very less thermal stability. It means it works at very low temperature, but it has very high active side, high active side, high active side, active side means, active side means this active side will, this active side only go for the reactions or go for the methane decompositions. Which part will react, which part will participate in the reaction, this is called the active side. Okay, next is the iron. Iron has very good thermal stability. It is slightly higher, that it can run 700 to 1000 degree centigrade, and if we use nickel, copper and carbon and other material, it has also high thermal stability, and different catalyst has a different advantages. Okay, generally we use that the nickel catalyst, cobalt catalyst and iron catalyst, and sometimes we will use the carbon catalyst too. Okay, and this is all the transition metal catalyst. Actually the transition metal, just you remember the transition metal catalyst. Transition metal catalyst means that the nickel, cobalt and iron, nickel, cobalt and iron is a very important. Okay, this is used as a catalyst, nickel, cobalt and iron, and carbon is also used as a catalyst, but I am in this slide, this is the nickel, cobalt and iron, this is the transition material. Okay, this is the transition metal. What is the transition metal? Transition metal has transition metal is the d block element. Okay, you know that d block, here one electron is filled. Okay, this is called partial filled electron, d block. Okay, as it is partial filled d block, what is the advantages of this transition metal? It can appear or it can easily react with the reactants, and easily the product formations will be easy. Okay, this is the things, whatever all the things it is written here. And sometimes we can use the nickel copper catalyst, and this is the, okay, not only for the good reactions, the catalyst is not only the final decisions. Along with the catalyst, we have to design or we have to choose the support material, because different support material has also, the different support material also enhance the reactions or reactions ability. Okay, this is the support material. Al2O3, MgO, Al2O3, this is the support material. Okay, and the, you just remember cobalt, ruthenium, nickel, RH, platinum. This is the higher activity. Activity is higher than the platinum, Re, iridium, palladium, copper, tungsten, Fe, molybdenum. This is done on the basis of the activity of the catalyst. Okay, this is the activity of the catalyst. Which catalyst? Transition metal catalyst. Okay, these are all the transition metal catalyst. The base transition metal catalyst is like nickel, cobalt. Okay, nickel, cobalt, ruthenium. Okay, okay, these are the things. And next, this transition metal catalyst, during the methane decompositions, what is happening, uh, uh, like this is support is Al2O3, MgO, TiO2, SiO2, ZrO2, zeolite. This is the support material. This is very promising support material. They are the generally used in the methane decomposition process. Okay, and promoter has also a significant role for the decomposition reactions for generating hydrogen. Okay, how this catalyst will be deactivated when our carbon in solid form generated. Actually, what happen if during this reaction, what is the product? Product is carbon in solid form. Carbon is solid form plus hydrogen gas in gaseous form. The advantages I already told you, that hydrogen gas will be separated and it will be coming out and you can store it easily. But this solid can deposit it on the catalyst. Like this is nickel catalyst. Like this is nickel catalyst. This carbon, if this carbon is deposited over the nickel surface, what will happen? What will happen? This, the active side of the nickel will reduce, and this active side will reduced, and the reaction rate will be reduced, and our main target will be not achieved, and the efficiency will be reduced. So this is very dangerous when the carbon deposition will occur on the nickel catalyst. Okay, but another thing, but the diffusion is good. This is the encapsulations of the carbon solid on the nickel catalyst is very bad, but the diffusion is good. What diffusion? This is the, suppose this is the nickel. Okay, diffusion means, suppose your byproduct carbon will diffuse it into the nickel catalyst. Okay, but when it will diffuse into the nickel catalyst, what will happen? The active side, obviously the active side will be outermost portion. This active side will still go for the reaction. Okay, go for the reactions. Like this, when the reactions will occur for a longer durations of time, this sort of, when the more number of the carbon will diffuse into the nickel surface, this will, suppose this nickel catalyst will placed on a support. This is a support. This is a support. Carbon will diffuse, the carbon generation, carbon form, and it will lift up this nickel catalyst. Okay, till then the nickel catalyst will work as a catalyst and it will participate in the reactions, it will generate the hydrogen. So we can say that the diffusion of carbon into the nickel catalyst is better than the encapsulations of carbon on the nickel catalyst. So the diffusion process, we may allow the diffusion process than the encapsulation process. Okay, So we have to design in such a way that the diffusion process will be higher, but encapsulations of carbon will be lower on nickel catalyst. If the encapsulated, if the carbon will, if the carbon is encapsulated over the nickel catalyst surface, the no active side will remain open and it will not participate in the reactions and the efficiency will be less. This is the simple things. Okay, this is the uh, carbon. This is the transition metal catalyst deactivation process. How the transition metal catalyst deactivated. Okay, over the period of reactions, over the time period of reactions. Okay, if I ask you the question, I have used nickel catalyst for one time. Obviously, after some time, after 10 hours or after 15 hours or after 1 year, okay, it will deactivate it. How the deactivations will occur? This is the process, encapsulation process and the diffusion process. The deactivations will occur. Okay. This is again the carbon-based catalyst. Previously, it was a D block element catalyst. Now the carbon based catalyst. Carbon is also used as a catalyst for generations of the carbon and hydrogen gas from methane decomposition process. The temperature is like 800 degrees centigrade to 1000 degrees centigrade. Okay. What is the main advantages? The main advantage is the low cost. Carbon has a low cost than the transition metal like cobalt, nickel. Okay, this is the low cost. That's why carbon is used for catalyst for hydrogen gas generations from the methane decompositions. Okay, what are the different catalyst? Carbon catalyst used for the methane decompositions. Just to remember, disordered carbon. Disordered carbon means that the carbon black, activated carbon. I mean activated charcoal. You also say, or amorphous carbon. Okay, can you give me one example that what is the disorder carbon and higher order carbon? I mean highly ordered carbon. Acha, do you know the highly ordered carbon? What is the highly ordered carbon? Any example of highly ordered carbon? Diamond. Diamond is a very highly ordered carbon. That's why the reflections from the diamond or scattering of light, okay, I mean splitting of light will occur. Okay, that white light will split it into 7 colors. Okay, diamond. This is the highly ordered carbon. On normal graphite is used for the pencil. Okay, this is also highly ordered carbon. Okay, but carbon black, activated charcoal, what is you may use in the purifications of the water. Okay, activated charcoal. Why this activated charcoal you will used in the water purifications? Because it has a lots of pore. It has a lots of pore. What this pore will do? The impure particle can be trapped inside the pore. Okay, easily. Okay, this is the things activated charcoal. Am I audible to you?
Yes, yes, audible.
Yeah.
Yes.
Okay. Whatever I am discussing, just it is getting. Are you getting? I mean, okay. Are you getting all the points? Whatever I am discussing.
Yes. Yes.
If you feel any doubts, you may interrupt me. Okay. These all the things already discussed by ma'am, but again I am discussing with you. Okay. Just for a the discussions will be more and you will get better understood. Okay. And these all the things whatever I discussed I told you. Activated carbon source like coconut, palm, olive, almond. Okay, these are the activated carbon source. Okay, from this we can generate, we can produce activated carbon. Okay, and already before I discussed the activated carbon properties or applications of the activated carbon material. Just see, carbon black. Carbon black means the carbon blacks. Carbon black has uh, why someone is calling. 1 second. Hello. Yeah, I have to allow you, na? Yeah, yeah. Actually, okay, okay. Just wait 1 minute. Okay. Uh, screen is visible, na? Hello.
Yes, yes, visible.
Okay, okay. Come to the point that the activated charcoal has a large number of pores. Okay, but carbon black has less number of pores. That's why. अरे यार, 1 minute. Someone is also try to come to the live sessions. Okay. The activate the carbon black. The carbon black has uh, very less number of pores, but activated charcoal has very high number of the pore and high number of the active sites. This high number of the active site can participate in the reaction, and this high number of the pore can easily filter filter your filter the solid waste water. Okay, that's why the activated charcoal will used for the uh, water separations or water purifications industries. Also, this activated charcoal or activated carbon is used for face wash. Okay, how this activated charcoal face wash is good? Okay, do you know that this is also the same concept, that the activated charcoal has large number of the pore or pore volume is very high. This high pore volume will what will that the particle, the impurities on your face will attract, and it will enter into the activated charcoal uh, pore, and this is how the impurities on your face will be removed. Okay, this is the main activated charcoal differ from the normal carbon or carbon black. This is also important, the type of carbon product. The type of carbon product, I told you that this CNT, when we use this nickel catalyst, the nickel catalyst carbon fiber will generate. This is the carbon fiber. Okay, this is the carbon fiber. This is the nickel catalyst. This is how the carbon fiber will generate. Okay, and when we use the iron, iron as a catalyst, CNT, carbon nanotube, carbon nanotube. this is very carbon nanotube. This is very good, or this is a very promising material for catalyst material, or this is also used in composite material. It is a high strength material. Okay, if we use this carbon CNT with uh, any material, we can, if we add it, if we use it as a filler, okay, the composite material will be high strength material, and it is conductive too. Okay, it is conductive too. This is a multi-wall nanotube. If we use the cobalt catalyst, it will produce multi-wall nanotube. This is the all various type of carbon in solid form will generate, and this carbon will again used in the different applications. Okay, then coming to the regenerations of the catalyst. Once the catalyst,
Uh,
yes,
In
yes,
a previous slide, you
yes,
discussed that iron forms CNT, but in next line it is mentioned that iron above 900 degrees centigrade into amorphous carbon or CNF or carbon flex.
yeah,
So that CNT is forming below 90 degrees, below 900 degrees.
no, actually the iron is, when suppose you have to design one reactions like decomposition reactions. Suppose I am telling you that I have one heat source that has maximum 600 degree centigrade, that has a maximum 600 degree centigrade, that can produce 600 degree centigrade. In that case, which catalyst you will took? Obviously you will not took the iron, because iron has the activations a 900 degree centigrade. Okay, you have to use, then we have to use the nickel catalyst. Okay, like this, the iron has a, you can, iron has a stability above 600 degree centigrade, sorry, above 900 degree centigrade. Up to 900 degree centigrade, up to 900 degree centigrade it can stable, but nickel cannot stable up to 900 degree centigrade. Okay, suppose I am telling you that the 900 degree centigrade reactions, which catalyst will be used? Nickel, obviously nickel will not used, because nickel will not stable at 900 degree centigrade, but iron can stable. Is it clear?
Yes, sir.
Yes, actually according to the temperature we will decided what catalyst will be used, because at higher temperature nickel will not, nickel has a very good active sites, nickel has a very good activity, I mean very large active site. It has very conversion rate is very high. Conversion rate means that the hydrogen productions from the methane, it is a very good, but we will not use when the temperature will be above 900 degree centigrade. In that case obviously you have to use iron. Okay, if we use iron as a catalyst, the carbon produce CNT will produce, carbon nanotube will form. Okay, if we use cobalt, multi-wall nanocarbon tube will form. This is the things. Okay, this is the very simple, just you have to remember these things. Okay, regenerations of catalyst. What is the regenerations of the catalyst? When the catalyst is used in reactions, obviously you have seen that the deactivations of catalyst, how the, what is the different process of deactivations of catalyst? There are two process of deactivations of catalyst. One is encapsulation, and second one is the diffusion. diffusion Diffusion, encapsulation and diffusion. Which one is better from our point of view? Which?
Diffusion.
Diffusion, because if the diffusions, we will always prefer diffusion, because the diffusion, if diffusion occur, the active site will not be drastically reduced, but if encapsulations occur, the active site will drastically reduce and the reactions will be very slow. Okay, reaction will goes down. Okay, how this suppose this is the catalyst and this is the carbon solid is forming or decomposed or I mean solid is encapsulating. Okay, the reaction rate will be lower. Okay, how we may regenerate this catalyst, because we will not, the catalyst is not will be used at a one time, we will throw it out and then we will buy new catalyst, new nickel catalyst, then we will again this use the new catalyst. We will not use, we will not like this is not like this. Every time we will regenerate this catalyst when the catalyst deactivations will be goes down. Okay, this is how the regeneration process occurs. You also know that the regeneration process, like if we use the water or steam. Okay, uh, this carbon, this carbon on the catalyst, this carbon will react and this will produce as carbon monoxide, as well as this will again it will produce hydrogen also. Okay, and this solid particle, deposited solid carbon will, if we use oxygen in this reaction, it will produce as carbon dioxide. Okay, and this carbon will be going out and carbon will be going out. Okay, and the catalyst can be again used in the reactions. This is the process of the regeneration of catalyst. Okay, sometimes metal and salt of methane decomposition. Okay, metal and metal salt is used in the methane decomposition as a catalyst. Metal salt or molten salt, like this is the liquid, this is the liquid catalyst, this is a liquid catalyst. Obviously the liquid catalyst can easily transfer heat to the reactions. Okay, for the methane decompositions CH4, and it will easily supply the heat and the reaction will be, reaction will occur easily, and it has a very, it has a little high efficiency. Okay, uh, okay, what are the different salt catalyst is used, like MnCl2 KCl. Okay, KCl and MnCl2 is used. Okay, and there is a temperature is always higher than the 1000 degree centigrade. Just you remember two or three metal or salt catalyst. MnCl2 KCl is used for this for the catalyst for the methane decomposition reactions. Effective parameter, this is again and again I am telling you that the temperature is also has the role in the reactions, and the pressure and the gas shift reactions. Okay, and this is the fluidized bed and packed bed. You know that the when we'll use the fluidized bed, that means the heat distributions will be uniform, uniform heat distributions, uniform heat distributions, uniform heat distributions, and the catalyst active site will be open, and when the catalyst active site will be open, the reaction rate will be high. For the packed bed, for the packed bed reactions, catalyst active site will be like packed. Okay, active site will be very less, the reaction rate will also less. That's why we will always prefer fluidized bed. And also for the fluidized bed, I told you that the very micro particle of carbon or micro for the solid fuel case, this is the micrometer or very smaller particle is used as a fuel. But here will I am using that the methane, it is no problem. But when you will use the carbon, fluidized bed carbon, okay, the carbon particle will be very at a small size. Okay. Next, this is the first topic, that the methane decomposition, and the second is the biomass energy. Okay, just I am checking it. One student is, I think, trying to join this session. Oh, I have to go faster actually. No one. I think has left. Okay. Huh. Biomass. You know the biomass. Biomass means just simple wood, tree. Just to remember that biomass means wood, tree. This is from the plant biomass. Obviously the biomass. Obviously from the human or human biomass is also there, like animal biomass is also like animal excreta, okay, and all the things, and and cow dung is also biomass, okay. This is the animal biomass and plant biomass. Generally the biomass is the plant biomass. And how the plant biomass is storing energy, it is exactly the energy is stored from the solar energy, okay. How the solar energy is converted into the solar energy is converted into the chemical energy or chemical bond, in which process, do you know the process? The plant uses this process. It stores the solar energy and it will form the chemical energy, photosynthesis.
Photosynthesis.
Yeah, exactly, photosynthesis process. In this photosynthesis process, the solar energy will be absorbed and it will, the reactions will occur and it will produce glucose, okay. And this glucose, okay, this glucose is biomass, okay. This is very simple. This glucose is biomass, or you can say in other word, the hydrocarbon. In glucose, carbon, oxygen and hydrogen, this is the hydrocarbon, this is glucose, this is the biomass. Simple things, okay. Just you remember these things. Typically biomass contain 55 to 65 gram hydrogen per kg of biomass. Means if we uh, in 1 kg of biomass, uh, this sort of gram of hydrogen is there, okay. These are the things, this is the basic things. And the source of biomass, you know that the source of biomass, the energy crop, okay. I am not discussing it further, in I am not taking longer time. Agro based industries waste, it is also biomass, it has also biomass potential, okay. uh, and forest waste like logs, chips, leaves, tree leaves, okay. These are the forest waste which are also considered as a biomass, okay. This has also potential for generating energy or generating hydrogen, okay. Municipal waste like biodegradable such as food, kitchen waste, green vegetables, like all the things are this is the solid waste, this is also biomass. The different source, agriculture waste, straw, pulse, okay, and seeds, all the things, these are the biomass, these are the source of biomass, okay. These are the source of biomass, different biomass source. All these all these things will contribute for generating hydrogen or energy, okay. These are the biomass source, okay. And these things, suppose tree leaves is also a biomass source, biomass. It is also a biomass biomass energy. It can generate biomass energy actually. How it can generate biomass energy? Suppose one tree is left on soil, or you are keeping tree leaves on a soil, during the natural process, what will happen? The decompositions will occur. Okay, the decompositions will occur, and in this decomposition, carbon dioxide and water will be byproduct. So there is no energy actually, but these things we can we can use in artificial ways. We can the advantages we can take the artificial advantages, like harness. We can harness the energy, like in like uh, in which way we can produce. Suppose some microbes or microbacteria. These microbacteria will decompose these trees, and this will generate energy in terms of carbon monoxide and hydrogen, because these tree leaves has glucose like hydrogen. Okay, this produces hydrogen and oxygen. Okay, this is the process actually. This is the biomass. Okay, and the carbon neutral, these things I have told you that when these tree leaves is directly burned into the open air, or in the natural process, the carbon dioxide will produces and it will go to the atmosphere. Okay, but here you see the process. If we go through the proper process, artificial process, this some energy will produce, some energy will produce. Okay, some energy will produce, and carbon dioxide, and finally the carbon dioxide will also produce, and this carbon dioxide will also taken by tree, and again photosynthesis process, again energy is harvesting into the trees, and again the trees is, if we burn these trees, and carbon dioxide will go to the atmosphere. This is the whole, the process is the carbon neutral process. Okay, and how the conversions of the biomass we will see, how the conversion of the biomass. Okay, this is very important, just I am discussing, just listen it carefully. There are three type of process. One is the biological process, one is the thermochemical process, and third one is the chemical process. Suppose biological process, in biological process, what is happening in biological process, like in biological process we will use, suppose tree leaves, animal excreta. Okay, suppose cow dung. Okay, these are the thing. Okay, just I should write actually. Suppose animal excreta, animal excreta, suppose cow dung. Another example of the biological source of biomass source, like cellulose, you can say cellulose. These are the things. What is happening in the biological process? In the biological process, some microbes or microorganism, some microbes will go, and this will decompose these things, and after the decomposition biogas will generated. Okay, or bioethanol will be generated. Bioethanol means C2H5OH, bioethanol. Do you know the what is the applications of the bioethanol? Bioethanol is very useful material, useful product. Bioethanol, anyone of you?
It
So
is
it is
mixed with
used
the
in
petrol.
blending in petrol.
Ha, 5% bioethanol is used in 95% petrol, and it is called power petrol. Okay, this bioethanol is used in the petrol diesel. Okay, now for automobile industry. Okay, this bioethanol or biogas or CH4 directly will burn, directly will in the petrol diesel engine, it is directly burned. Okay, and the energy will produce. This is the simple things. And next come to the thermochemical process. Here the thermal and the chemical process is, this is the previously was directly only was the thermal process, but here the chemical process is also done. In the thermochemical process, the combustion process, combustion, gasifications and pyrolysis. In combustion process, suppose tree leaves, if we use cow dung is also a source of biomass. If we reduce, if we dry it up to a certain level, what will happen? The moisture will be removed, and the cow dung, if we combustion is done on the cow dung, the energy will produce. This is a very simple process. If we take wood log, if we remove the moisture from the wood log, and if we burn it, and the energy will produce. Okay, this is the combustion process, simple combustion process. Combustion process is uh, combustion process is a process that occurs in the presence of oxygens. Okay, and it will produce heat energy. Okay, in the gasification process, all the in the gas, what is the gasification process? In the gasification process, just I am doing combustions in the presence of anything. In the gasification process, some gas will produce. Like in the gasification process, suppose animal excreta or glucose glucose, if we burn, okay, some gases will produce, like producers gas, like carbon monoxide, hydrogen, okay, and CH4. These are the things. This is called the producer gas. Okay, and this producer gas can produce hydrogen. Okay, and hydrogen, you know that the hydrogen is also one form of the energy. Okay, and the pyrolysis process, what is the pyrolysis process? This is pyrolysis process is the absent of oxygen. Okay, absent of oxygen, if we burn it, it will produce bio oil. Okay, bio oil, just I will show you how the bio oil is generating from the biomass. Okay, and the chemical, finally the chemical process is the biodiesel is a chemical process, and it is directly producing energy. uh, Biomass, what is the compositions of the biomass? Simple, you know that the tree is a biomass. Okay, tree is a biomass. In tree, wood wood is a biomass. Tree leaves is a biomass. Cow dung is a biomass. Okay, this is biologically produced. Okay, or residues is a biomass. Grasses is biomass. Just you remember these things. In grasses, in hardwood, there are cellulose, hemicellulose, lignin. These are the uh, chemicals. These are the chemical inside the wood. Cellulose, you know that the C6 CH, carbon, hydrogen or oxygen. Okay, it has some formula, you just go through. And lignin, what is the lignin? Lignin is a this is the name, chemical name. Lignin is, just you remember, the lignin is a very high strength glucose. High strength it has a very high strength it has a very high strength. Hemicellulose, it is a just cellulose and hemicellulose, just if you broke it down, the hemicellulose will form. Okay, and lignin is a very tough material. Okay, it has very high strength. Okay, these are the things. Actually, wood is a combination of cellulose, lignin, hemicellulose, as well as some inorganic material too, or some inorganic salt is there. Okay, like NaCl, Na2CO3, and Na2S, like this. Okay, this is the biomass compositions. Uh, this is the things, cellulose base, and chemical is the biodiesel, fatty acid, oil, fatty acid. This is the from the fatty acid, oil we can produce the biodiesel. Okay, and from the cellulose we can produce a biological process, and thermochemical, pyrolysis and combustion, gasifications. Already I discussed you. Combustion process, you know that this is the presence of the oxygen or water, complete oxidation of the biomass. It is called combustion process. The definitions is very important. Okay, and the residue will like inorganic solid residue, and heat and light is the heat and light will also produce in the combustion of the biomasses when we will make when combustion process is occur. Next, in these things, pyrolysis, gasifications, and combustions is have shown you have illustrated here in this figure. What is happening? Uh, this this yellow luminous color is what is the this yellow luminous color? Do you know what is happening? This is also combustion. All the things is the combustion. Combustion is the combinations of gasifications and the pyrolysis. These combustions and these combustions. This is the liquid combustion and this is the solid combustion. Because why this is sorry, this is the gas combustion. Okay, because this is the matchsticks is also a wood, soft wood. Okay, it has cellulose. Okay, cellulose means that the, you know that the carbon, hydrogen and oxygen. Okay, when we will give the heat, when we supply some heat, okay, it will produce some liquid or some gas. Then with the excess of the oxygen it will produce some gas, and then the gas will be burning like this in a luminous form. So this is called liquid combustion or gas combustion or liquid combustion. This is solid combustion is like this is only the solid is combustion. Okay, inside the matchsticks. These are the things, all the things, these are the things. Okay, after the combustions there is a biochar. It is the form of carbon. Okay, biochar. Biochar is also useful material. Okay, in some applications. Okay, it is the same things already I discussed that the these things, this is the cellulose. If we provide some heat in the cellulose, uh, first what will produce C6H8O and liquid bioil. This is called liquid bioil. If we if we give some heat and temperature to the wood, what will happen? It will not immediately, it will form combustion gases, hydrogen, oxygen and carbon dioxide and carbon monoxide, and carbon will not form. In between, liquid bio oil will generate. We can extract this liquid bio oil. If we condense, this liquid bio oil can get. Okay, and oxygen, hydrogen will produce, and methane, carbon monoxide and carbon dioxide oxide will also produce, and finally after the proper combustions, complete combustions, the biochar will form. This is the process of if we do fast pyrolysis, means that the fast pyrolysis means at moderate temperature and short residue time, uh, what will produce? This liquid bio oil will generate. If we provide some temperature, if we provide some heat for a short resident time, for a very less time, this liquid will produce. If we need, if you need this liquid bio oil, then you have to go for the fast pyrolysis. Means that the means you have to put the a biomass for a lesser time. Slow pyrolysis, then it will produce almost similar amount of the liquid, char and gas. If we go high temperature and long residue time, obviously all the things will be burned out, okay, and the obviously finally the gas will produce the carbon monoxide gas and hydrogen gas and carbon dioxide gas will produce, okay, and the char will very less percentage char and the very less percentage liquid will produce, because all the things is completely combustion is done here for the gas productions at high temperature and longer residence time. This the how the breakage of the biomass is here. This is also I have discussed in the previous slide, the how the breaking is also occur. Here just you remember that the carbon hydrogen bond is bond energy is higher than the carbon carbon. That means that means the carbon carbon breakage will occur here. Okay, some higher energy will F will attack in the carbon carbon bond and the carbon bond will be break, okay, and this way, and in this way the higher order carbon will be break down into the lower order carbon. This is the things. Biomass gasifications, gasifications means that the it is the process of producing the gas, okay, from solid fuel or liquid fuel, okay. Gasifications also like this, that the carbon plus oxygen, uh, carbon dioxide, carbon monoxide, these are things the gasification process, okay, and these things are important things. Biomass, this is the biomass. If we do pyrolysis, pyrolysis means, do you know the pyrolysis means? Absence of oxygen, it will produce some volatile matter, okay, uh, volatile matter, and the rest of the charcoal will produce, and this charcoal will participate in the reduction reactions, and after the reductions of the charcoal it will form the carbon dioxide and water, and again this volatile matter for the case of the matchsticks, it will produces some volatile matter. This volatile matter in the presence of oxygen will be burning, and carbon dioxide will gas is produced, and finally this carbon dioxide gas plus water will go for the process and it will produces the syngas, okay, and this is our product, this is our main desired product. You know that the pyrolysis process is the zero 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 oxygen, uh, at zero oxygen level. A gasification process is done some substoichiometric oxygen process like 0.2 to 0.4 percentage, okay, and combustion process is excess of oxygens, okay. This is the basic difference, pyrolysis, gasifications and combustions. What are the four steps of the gasifications? This the first is the drying process. Suppose you have one wood chips, it is wet wood chips. Firstly you have to dry it for the proper combustions, okay, just you dry below 200 degrees centigrade, and then if we add above 200 degrees centigrade, it will produce some uh, charcoal and tar, and this if we again the increase the temperature, it will produce the water and carbon dioxide, like in tarry gas and charcoal, then the carbon dioxide and water will form, and finally the hot charcoal will remain, okay, and the reaction process is these things: C plus H2O, carbon monoxide and hydrogen, and this the all the gasification process reactions. In all process the gas is producing, that's why the this it is called gasification process. And gasification process, this is the one reactor in the gasification chamber, you can produce the hydrogen gas, okay, or all the gas combined together. A biomass this is the same things you just go through. Okay. Actually, just I am going fast because time is less. Actually, the role of steam. You know that the role of steam is used for the carbon monoxide shift, water gas shift reactions. It will produces hydrogen again. Okay, and the hydrogen productions and the hydrogen will be higher in the downstream. Okay. Acha, okay. Next, okay. Next, I am coming for some MCQ questions. Okay. Is it visible the MCQ questions, or I have to zoom it?
Yeah, we can see.
Yeah. Actually, just I am okay. Okay. We'll discuss some sort of MCQ questions, and we'll discuss such that you can just somehow you can remember the basic understandings, or you can remember these questions. Okay. It will helpful for your future, or in future applications. What is the temperature range of the catalytic methane decomposition process if the Ni is used as a catalyst? It is very important. If Ni is used as a catalyst, what is the decomposition temperature? Is it 900 degrees centigrade to 1100 degrees centigrade? From 1100
No,
degrees centigrade to 1300 degrees centigrade, 500 to 650, 1500 to 20.
500 to
Exactly,
650.
exactly, 500 to 650. Because I already discussed that nickel catalyst can withstand low temperature. Nickel catalyst, low temperature withstand. It is, it has very less thermal stability, thermal thermal stability, LITY, less thermal stability, less. Nickel catalyst has a very less thermal stability. Obviously, the nickel catalyst will used below 700 degree centigrade or 650 degree centigrade. That's why our option C is correct. Next, question number 2. Which type of carbon structure has high catalytic activity? Disorder carbon structure, intermediate carbon structure, order carbon structure, and graphite.
A, disordered.
Disorder carbon structure. Acha, here you can see that option C and D, order carbon structure and graphite, both are the same
Both
thing
are
actually.
same.
Both are the
Same.
same thing actually. Intermediate carbon structure means that the order carbon structure amorphous and order semi-crystalline. It is called actually semi-crystalline. Actually, you know that the order structure, order over DE or ordered ED, ordered structure plus disordered structure. It is called disordered structure. Order plus disorder, disorder. It is called semi-crystalline material. Semi-crystalline, semi-crystalline material. If one material is very good ordered structure, like an example diamond or graphite, okay, this is called crystalline material. Okay, suppose this is called crystalline material. Suppose uh, some polymer is always semi crystalline material, means that the some molecule is orderly form and some is disordered form. Okay, this is called semi crystalline material. Question number 3. Which among the following is mixed in petrol? 50% ethanol, 5% methanol, 10% biodiesel, 5% ethanol.
5% methanol. B.
Exactly, 5% ethanol.
5% ethanol.
Huh. What is the formula of the ethanol? C2H
C2O5OH.
C2H5OH. OH group is, as is OH group is there, it is called NOL, ethanol. Okay.
Alcohol.
Alcohol, exactly. This is alcohol group. Okay. This is alcohol. Methanol is also a alcohol. Okay. Which one is more poisonous, ethanol or methanol?
Methanol.
Methanol. Then the question number 4: which of the following method gives direct energy from biomass? Biological combustion, pyrolysis, gasifications. Biological,
Combustion.
Combustion.
why the combustions?
Direct burn and we get the energy.
Combustions is done in the presence of oxygen, and we are getting energy. We are getting energy. ENER. We are getting energy. We are not getting hydrogen. For hydrogen, we have to go through. For hydrogen productions, we have to go through what process? For hydrogen productions,
Either
we have
pyrolysis,
pyrolysis
either
and gasification
pyrolysis.
process.
Yes.
Gasification is common because gas is produced, that way gasification process. We have to go to. So this is very important that for the energy, heat energy means heat energy. If we do combustions on biomass, then heat energy will produce. Okay, there is no hydrogen productions. If we burn the wood or cow dung, it will not produces hydrogen. It will produces energy, heat energy, but there is no hydrogen you can get. But hydrogen you can get if you go through the proper process, pyrolysis process and gasification process, you can generate hydrogen. Okay. So the proper answer, correct answer is the B, na? Is it clear? Next question number 5. What is meant by pyrolysis? Complete oxidations of the biomass fuel to carbon dioxide and water ash, breaking down the organic compound under the heat in presence of oxygen, breaking down the organic compound under the heat absence in the oxygen, breaking down the organic compound under the heat in presence of nitrogen. Pyrolysis means what?
The answer is already displayed.
Oh, okay. Actually, I made one PPT earlier, but somehow it was not saved. That's why I do it. Okay, no issue, but we have to just remember, we have to study again and again. So that's why we can remember all the things easily. Okay, that's why this is the main goal of this lecture by our this PMRF TA actually. Okay, ma'am is doing good, excellent, and you can understand better there. But we here are just here for support you. Okay, for the again and again discussions. Okay, such that you can remember all the things easily or you can clarify your doubts. What is the mean by pyrolysis? Pyrolysis means absence of oxygen. First you see the absence of oxygen, okay, and breaking down the organic compound. It is only the breaking down the organic compound. It will produce it will produce just CHO. It will break and it will produce in the presence of oxygen. High volatile matter will produce. Okay, so answer C is correct. The condensate obtained during pyrolysis is termed the when the condensation is done, obviously your bio oil will generated. Okay, because you will do pyrolysis process, pyrolysis process pyrolysis process. Firstly, the volatile organic matter will produce. If you condense it, okay, it will coming as a liquid material. This liquid is called the bio oil. Okay, and again this liquid is heating, then it will produce the char. Okay, or carbon. Okay, or residue, carbon residue. Okay, so bio oil. Is it clear? What is the calorific value of the lignite coal? Lignite coal, what is the good quality, which coal has a very high calorific value? Do you know? There the coal classification.
I think anthracite,
Ha, anthracite. There are four types of coal: anthracite, anthracite, anthracite,
bituminous,
anthracite, bituminous,
uh,
lignite,
lignite. Yes.
lignite or pit. Anthracite, bituminous, lignite, lignite, and peat. PEAT. Sorry, PEAT. Peat. Actually, peat is a very lower grade coal. It has very low calorific value. The lignite is somehow better than the peat. It has some higher calorific value. A bituminous has higher calorific value than the lignite, and anthracite is very high calorific value, and it is very good type of coal. Okay, anthracite has very higher calorific value, like 35 to 40. This is anthracite, and 27 to 30. This is the lignite. Okay, lignite 3, and bituminous has between. Okay, the peat has very low, like 27, below 15, actually below 15 peat. This anthracite type of coal, this anthracite type of coal is found largely in Australia, actually. That's why some, you have seen, I think, the coal from good strain that carry, sometimes it is written that Australia, from Australia. Okay, and in India, lignite and bituminous type of coal is found. Okay, question number 8. Question number 8. In the air gasification process of biomass, the typical yield of hydrogen is like, the typical yield of hydrogen. This is the, remember, a kind of questions. Okay. This is, I will not suitable prefer, but you have to remember these things. Okay. What is the process? You have to just remember, actually. This is the D, 30 to 40%. Okay, yield.
35 to 40.
Hmm, hmm. Next, question number 9. Which among the following acts as a residue agent in order to obtain syngas on the biomass? Charcoal. Charcoal reduction process. Charcoal will be reduced. Okay, and it will produces syngas. Okay, carbon monoxide plus hydrogen. This is A. Question number. And what is this process? This is also kind of a gasification reaction. This is also gasification reactions, but type of gasification reactions is the Bodo reaction. Okay, just carbon and carbon dioxide will produce carbon monoxide. This is a Bodo reaction. This is also gasification reaction. All the things of the gasification reactions under the classification, under the category of the gasification reactions. This is the this is called Bodo reactions. Okay, I will go for this numerical. Okay, okay. There are 30 minutes left. Okay, I will go for this numerical. Okay, I don't know. Someone is trying to join. Just let me check. Okay. Okay. Those who are joining in late, but you may join, but I have no problem. Actually, sometimes I have to I have to come to the Google slide, then I have to go. Yeah. Okay. Come to the one numerical. Okay. The given, this is the ultimate analysis of a result. What is ultimate analysis? What is ultimate analysis? Ultimate analysis is, just let me take. Ultimate analysis, it is determining the carbon, hydrogen, oxygen, sulfur, and water molecules present in the biomass or present in the fuel. How much weight percentage? How much weight percentage? Weight percentage. How much weight percentage? This carbon, hydrogen, oxygen, sulfur. These are the things present in the biomass or fuel. This is called ultimate analysis. So the result shows that one ultimate analysis, the carbon is 45% and hydrogen is 6% and oxygen is 49%. Okay, the result shows that carbon is 45% carbon, hydrogen is 6% and oxygen is 49%. You have to calculate or you have to find out what is the empirical formula of this biomass or of this fuel. Obviously, as it is shown, as it is given that the fuel is composed of carbon, hydrogen and oxygen, obviously it has some, it is formed that the carbon, hydrogen and oxygen. And what is the x value, what is the y value and what is the z value, you have to calculate. What is this x, y, z? This x, y, z, do you know what is the x, y, z? This is a mole fraction. This is the mole fraction. So you have to find out the mole fractions. Okay. In the questions it is given carbon is 45%, hydrogen is 6%, oxygen is 49%. If we do total is 100%. So, okay. Suppose 100 gram of fuel, suppose 100 gram of fuel, suppose 100 gram, suppose 100 gram fuel, suppose 100 gram fuel, in 100 gram fuel there are 45 gram carbon, 6 gram hydrogen and 49 gram oxygen. Okay, and you have to find out the mole fractions. Okay, so how we can find out the mole? We can easily find out how much carbon is present. The Asha, I am taking different color. Let me take black or okay. Suppose 45 gram carbon. 45 gram carbon. The molecular weight of carbon. The molecular weight of carbon is 12. The molecular weight of hydrogen 1. The molecular weight of single O, I mean single O, is 16. ठीक है. This is molecular weight means this is the molecular weight. This is the molecular weight. Molecular weight means 12 gram per 1 mole. 1 gram per 1 mole. 1 gram per mole. This is means for carbon 1 mole carbon has a weight. 1 mole carbon has a weight. 1 mole carbon weight is 12 gram. 12 gram. Okay. 1 mole carbon is 12 gram. How many gram? 45 gram carbon equals to what? 45 gram carbon equals to how much mole?
45 by 12.
Exactly. 45 by 12. Just you calculate. 45 by 12 will be
3.75.
3.75. Sorry, 3.75. It is clear, na? 3575 mole, na? But our main target is find out the mole fraction. But here it is the mole, carbon in terms of mole. Similarly, if you calculate what is the hydrogen in terms of mole, 6 gram hydrogen in terms of mole, obviously 6 by 1,
6.
6, 6 by 1, na?
Yes.
So 6 by 1, 6 by 1, it is 6 mole. Okay. Similarly, oxygen mole, how much mole of oxygen is there?
3.06.
49 divided by 16. It is coming 3.06. This is a mole. So that means 45 gram carbon, that means 3.75 mole carbon. 6 gram hydrogen means 6 mole hydrogen, and 49 gram oxygen means 3.6 mole oxygen. Okay. Okay, but you have to find out the mole fraction. Okay, how you can do mole fraction? What is the formula of mole fractions? Mole fraction means simple. Mole fraction is, bolo. Mole fraction means, suppose mole fractions formula. Mole fractions is this is the mole fraction. Mole fraction means, suppose carbon mole fractions. Okay, carbon mole fractions. Carbon mole, total mole. This is the total. TOTL, total. Writing pad is not good actually. total mole divided by, sorry, total mole, okay, not total mole, mole
Y
fraction,
carbon divided by Y total.
y carbon divided by y total, just a little bit of corrections actually I have to do. Y carbon divided by y total, so y carbon equals to y carbon 3.75, 3.75, okay, and total mole, if we add these things, this carbon, this oxygen and this hydrogen, if we add it, it will coming 12.812,
12.81.
12.812. The y carbon mole fraction is coming, yeah, it is coming 0.292. This is our mole fraction of carbon. This is important. Similarly, if you calculate the mole fractions of, just I am taking different color, red. Similarly, if you calculate the mole fractions of Y hydrogen, the total mole of hydrogen, how much mole of hydrogen? 6 by total mole equals to 12.812. It is coming
0.46.
0.468 mole fraction of hydrogen. This is the mole fraction of hydrogen. Similarly, if you have to calculate the mole fractions of oxygen, just I am taking different color. Is it green? Okay. Okay. Similarly, Y oxygen will be, oxygen how much? Oxygen is 3.06. 3.06 divided by total mole, that is
0.38.
12.812. It is coming, it is coming 0.239 na, 0.23,
0.239.
this is the mole fraction of oxygen, hydrogen and carbon. Okay, just put the xy value, you will get the answer. C will be mole fractions, X is the mole fractions of carbon, like 0.292, and hydrogen will 0.468 and oxygen will 0.239. Okay, and if you do some modifications, like if you this is the empirical formula of biomass, this is the biomass empirical formula. Just you, if you want that the carbon will be 1, for looking good, carbon will be 1, we do not write 1 generally, just you divided it, all the divided by 0.292. Okay, it will, like carbon will 1 and hydrogen will be like 0.468 divided by 0.292. and your oxygen will be this divided by 0.292. Okay, if we do calculations, if we do, it will coming, it will coming C1, it will coming C1 H 1.6, H 1.6, and oxygen 0.82, 0.82. This is your answer. This is how we can formulate the empirical formula of any biomass. Okay, just to remember, the you have to calculate the mole fraction and put the mole fractions in the formula Cx, Hy, and Oz. You will get and you can solve it easily.
Sir, why we are not considering a H as a single one instead of a carbon?
I am not getting you actually. What you were telling?
Sir, my question is that why we are not considering a H as a one instead of carbon?
Acha, why we are not considering? Why I have considered the carbon as a one?
Yes, sir.
Okay,
Instead of
okay.
hydrogen, you are
Okay.
finding
You can
hydrogen only.
you can do it. You can do it. This is suppose according to your MCQ questions, you have to rearrange it. Suppose, okay. Suppose if you want to do hydrogen as a one, just you divide it by, just you divide it by 0 point these things, just to divide it by all the 0.468. Just I am taking it in red color. You divide it by, you divide by 0.46, it will come, hydrogen will come 1, and just divided this by 4 point this, and this by 4.468. Okay, you can do hydrogen as a 1, you can do anything as a 1. Okay, it is no issue, but the ratio is the same, mole fractions. That's why always mole fraction, in terms of always mole fractions we will calculate. Okay, this is a mole fraction. If you do anything, there is no problem. Okay, okay. These sort of questions generally will asked in your examinations also. Okay, this type of questions you will get. This type of questions were very simple. Just it will take 2 minutes. Okay, just it will take 2 minutes. Calculate. Okay, I think you can easily do it. Okay, if you do 1 or 2 time practice, you will get solved. One question is also I have one question, but it is very large questions. I will not go for now actually. Okay. Uh, if you have any questions, you
Sir,
can ask me.
since I have joined late, do we have a recording for this session?
Yeah, yeah. I have recorded it. Yeah, I will upload it into YouTube. We have one. We have one WhatsApp group. Immediately, I will share the link in WhatsApp group, and obviously, you will get the YouTube link through the NPTEL team, from the NPTEL team also. Okay,
Sir,
okay.
can we join that WhatsApp group?
Yeah, you can join in WhatsApp group. You can join the WhatsApp group.
To join, sir?
How you can join? Just anyone of your mates will share the link of the WhatsApp group, and you will join.
Sir, I don't know anybody here.
You don't know. Okay, just my anyone of you just you can share. Can you share WhatsApp group link in the chat box? Please send. Can anybody send? Or also you can share your number such that your friends can join, can include in this WhatsApp group also.
Sir, I have shared in the chat message.
Yeah, yeah. Just I am sharing. Uh,
Thank.
Invite link. I have to actually mail. Okay, let me do it.
Subrata sir, can I have your number?
Yeah, yeah. My number is in WhatsApp group. Just I'm
Uh,
sharing the link actually. Okay,
okay, sir.
I'm sharing the. Can you share the link? Actually, I am doing from a laptop. You are doing from mobile, na? You can share it easily. You can share it, na?
Sir, I don't. I am not in any group. That's why.
Anyone of you don't have?
Sir, if you can share your number, I'll text you hi.
Okay. Uh, 90 just 9064824402. Just
Sir, nine.
huh,
Sir, 90
9064
64
824402
8244.
02.
Okay, sir.
Actually, what all of are you doing now presently? Why you are joining this course?
Sir, I have messaged on WhatsApp.
Yeah, yeah. Okay, I am sharing. This
The
is the
link is
group.
also shared in the group.
Yeah,
Yes,
yeah.
miss.
Thank you, thank you. Okay, you can just copy it and you can use for future. Okay. I think all of are you students or you were from industries like you were doing something or you were having your own business or I don't know. Hello, hello, Deepak sir. You were hello, hello.
Uh,
Yes,
Hello, I am
you were having
railway-
your
yeah, I am from the railway industry. I
acha
am looking at hydrogen fuel train.
acha. Okay, you were as a section engineer.
I am from private company Tufnord. This is a
Co-
safety assessment company, and I am basically from the railway and metro industry.
acha, which company? Just
Tufnord is German-based company. Yeah.
Yeah, yeah. That's nice. Okay, okay. You are looking for hydrogen based rail.
Yes, hydrogen fuel-based train. Yeah, this
Yeah,
is
yeah.
in pipeline Indian project. Megha and BHEL is working on that.
Yeah, acha. BHL is working on that. Okay. Actually,
Mm.
for that case, hydrogen based train.
Yes,
Okay,
yes, hydrogen
okay.
fuel-based train. Yeah.
Fuel based train. Actually,
Yes,
obviously you have to use liquid hydrogen
correct, right, right.
because liquid hydrogen is used in the rocket propulsion. I mean, for
Mm.
the
Yes,
propulsions, jet propulsions.
yes, yes.
Otherwise, it is very difficult to
Yes, this is very
design the
difficult
train.
task, but yeah, this is a very difficult task, but railway board is trying to start this project.
Yeah, yeah, yeah.
Mhm.
Hmm. This is possible. Just you have to use the liquid hydrogen, and then the combustion chamber you have to design like
Yes, their design is already prepared by some foreign company. This is
yeah,
some JV with BHEL or JV with some Titagarh. Titagarh is Kolkata-based
Titagarh,
company.
Kolkata. Yeah, I know. My
Yeah.
hometown is
So
also.
there is, yeah. So there is JV. Based on JV, we have there have some few designs.
Yeah,
How will
I think.
we
Yeah, yeah.
uh,
I think I am also working actually.
Basically, there is electrolysis based on which are the
Exact.
battery and battery will operate the train, something like that.
Exactly. What is happening in the first class? I told you in the first lecture. If
Mhm.
you see my lecture, what is
Mhm.
happening that hydrogen there is hydrogen gas. Okay, this hydrogen gas
Mhm.
will enter in the fuel cell. This fuel
Mhm.
cell will generate electricity. This electricity will help for
Yes.
running the motor
Yes, propulsion. Yeah, right.
propulsion, and this motor will accelerate axle wheel, and this is
Yes,
the
yes.
way the
The
train
same
will be.
concept.
Yeah, this concept. But
Mm.
actually what is happening, this fuel cell has a fuel cell for storing the energy, electrical energy.
Mhm.
You have to require large number of the battery like lithium ion battery.
Definitely. Definitely.
These the lithium ion battery we have to this is the main things actually. Whatever the
Mhm.
Toyota Mirai, it is the
Mhm.
hydrogen fuel cell car,
Mhm.
innovated by our doctor, our home minister in India. Only one car
Mhm.
is there in India, that is the Mirai Toyota. It is powered by
Mhm.
fuel, hydrogen fuel. Okay,
I
this con
think one fuel
Nitin
Nitin Gadkari inaugurated. I
Nitin
think.
Gadkari
Yes,
inaugurated
yes.
this. Okay, huh.
Mm.
This concept they are trying to utilize. This concept they are trying to utilize in the train sector. Okay,
Yes,
but
yes, yes.
this will be very difficult because one four-wheeler car running is very easy than one train. Train has a
Mhm.
very
Mhm.
high weight, all the things, but we have to scale it up to a certain level.
Yes,
Yeah,
yes, yes,
that is the challenges actually. Yeah,
yes,
uh,
definitely.
in this project I am also working. Actually I am also working in the electrolysis. In our lab
Mhm.
there is also fuel
Mhm.
cell. In the
Mhm.
last lecture I will show you our
Mhm.
lab, and what we are doing, all the things we will show you all.
Yes, yes,
Yeah,
yes.
yeah, thank you. And
Yes, sir.
Rajendra Singh,
Good
go.
evening, good evening, sir. I'm Deepak.
Yeah, yes
Deepak.
sir, good evening sir.
Yeah, I'm general manager projects working in the multinational company.
Yes sir.
And we are doing mostly the steel industry and mineral separation
Yeah,
government plants projects.
yeah,
So actually, it is my personal own interest, and I'm designing this solar rooftop, grid
yeah,
connected rooftop solar power plant and all this for the government projects.
yeah,
So that is why, because it is the new fuel system.
yeah,
So that is why I joined this course.
yeah.
And what sir is saying that running of this electric
Electric
engine
car,
by this battery,
uh,
electric engine by battery,
battery.
then I I'm having the doubt that whether this horsepower will be generated by the battery for the starting torque requirement for the engine, all this.
Yeah, horsepower is no issue, but whatever I read one research paper or I
Yes,
discuss someone, what is the main challenges is coming that if we use a large number of the lithium ion battery in
yeah,
a very small area or very compact area, what is the problem? The heating up of the lithium ion battery is very high, and it can easily, it can anytime burst. Okay,
oh,
and the protections of human life should be there. That's why
yes,
they are thinking that nanofluidic heat extraction device or channel, such that actually we have to cooled up the lithium ion battery. Okay,
yes,
because is such a large number of the horsepower is generating and coming from the lithium ion battery, and lithium ion battery will be very heated up, and this lithium ion battery is very heated up, and it can anytime burst, or it can explosive, it is very explosive. That's how that is why that the lithium ion battery cooling is a very good challenging issue nowadays. Okay, now Singapore University, that is the NTU or NUS, they are working on this lithium ion battery cooling. Okay, and this is the
but
topmost one university.
whether it will be the cost effective,
Huh,
like
yes.
whether
Actually,
it,
initially the governmental first target is not the cost effective. Cost effective is also one main target, but initially target is that up to 2030 there is at least 20 to 30-40% cars should be converted into the electric vehicle. Okay, next up to 2050 all the car will be converted into the electric car. There will be no fuel conventional fuel uses car, no petrol diesel car, there will be no petrol diesel car. This is the main motto of the central of the global government, but
So
we are lagging, we are lagging it.
if we use the hydrogen fuel cell in the car,
Hmm.
then there is the possibility also that we can charge that battery, main battery,
No,
not
no,
the
no.
hydrogen fuel cell, by the electric supply also,
Yeah,
as
yeah.
we are doing in the conventional. So by the both the way we can
Ha
charge
ha
that
ha ha.
battery.
Both, by both the we can charge the battery.
Yeah,
We can use the external electricity for charging the battery.
yeah,
We can also install the fuel cell.
yeah.
From the in the fuel cell, hydrogen will be given into the fuel cell, and this fuel cell
That
will
will
generate
charge.
electricity, and
Yeah,
this electricity will charge the battery,
charge battery.
and
Yes,
this is how the engine will operate.
yes. So, like we are saying that suppose this EV car capacity is the
EV.
200 kilometer or something,
Yeah, yeah,
so that can be removed by this use of the hydrogen fuel cell.
yeah. Actually, the electric motorcycle is running successfully in the inside the city. Actually, it cannot
Yeah,
be good for the outside of the city, but inside the city you can use the battery motorcycle.
yes,
Yeah, yeah. This has you can up to 60 kilometer, 50 to 60 kilometer. If you do charge at a single time, this is good inside the city. If you travel 50 or 60 kilometer, it is good.
yeah, that is good because for
Yeah,
the office going and coming, it
ha.
comes near about 30 to 40
30
kilometer.
to 40 kilometer,
Yes,
and it is okay. And in your office also you can make some charge. Yeah,
yeah, yeah.
but,
There are
but
the facility in
yeah,
our offices
yeah.
also.
That's the way. That's the only way we can decarbonize the global decarbonization's goal can be achieved.
Yeah,
Yeah.
and we can
Okay.
save the foreign exchange also.
Yeah. Actually,
Thank you.
India is lagging behind, but already Japan has already developed their hydrogen car, and US is also very good in it is they are also advancing their thoughts. whatever I am doing, that I am not getting the material of the water electrolyzer for the good kind of research material from India. I have to buy the carbon cloth and the titanium felt and titanium sheet and all the things I have to buy from USA, and it is too much costly. Okay, that's how we are lagging behind in research as well as innovating something.
Yeah.
Yeah, this is the things. Okay, thank you,
Okay.
sir.
Thanks, sir. Thank.
Hmm.
Nice lecture.
Okay. We'll discuss it next classes also. Okay.
Yes, sir. Yes, sir.
Okay. Thank you. Bye.
Thank you, sir.
Okay.
Bye.